come back, 11 and 12. Here's example 2. Here we're given this probability of A is equal to 0.3. Probability of B is equal to 0.5. And it's find probability of A or B if we're given these two conditions. So our solution will be as follows. So saying A and B are mutually exclusive events. First point, write a condition for mutually exclusive events. And you say they cannot occur at the same time if two events are mutually exclusive. So they've got a zero intersection. Probability of A and B is equal to 0. So that is for mutually exclusive. You get the mark for writing this. Now next step, now they say find A or B if this is the case. So to get probability of A or B, you have to use the addition rule formula, which says probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Probability of A or B is an unknown. Once you find it, probability of A, given it's 0.3, probability of B, it's 0.5. Probability of A and B, it's 0 because these two are mutually exclusive. We are given that here. Or we are assuming that they are mutually exclusive. So it's going to be 0. Then we'll get 0.8 here. That's our answer. For number B, they are saying if A and B are independent. Also find A or B. Probability of A or B. So first point again, the condition for independence. So if two events are independent, we say we multiply their probabilities to get the intersection. Probability of A and B will be probability of A times probability of B. Why? Because they are independent. But now we've got probability of A, it was 0.3. Probability of B is 0.5. So 0.3 times 0.5 gives us 0.15 is the probability of A and B. Are we done? Now we want probability of A or B. How are we going to find it again? We're going to use the addition rule formula, which I wrote here. We substitute to it. Probability of A or B is our unknown. Probability of A is 0.3. Probability of B is 0.5. And the probability of A and B is 0.15 now, because we found to be 0.15 for these independent events. And if you punch this in the calculator, you get 0.65. So you see you're getting different answers depending on the conditions, whether we're assuming that A and B are independent or A and B are mutually exclusive events. And you see how important it is to know the conditions for independence and mutually exclusive, and how important to use the addition rule formula. Next example, example 3. They say events A and B are mutually exclusive. Underline that, mutually exclusive. Think about the condition for mutually exclusive. And just given this probability of A is equal to that, probability of A or B is equal to 0.57. There is a find probability of B. So our first step is always we write the condition for mutually exclusive events, because we are given that they are mutually exclusive, these two events. So we're going to say probability of A and B will be what? Will be 0. Why? Because they are mutually exclusive. That's the condition. Mutually exclusive events. So we want to find probability of B. We're given this. Then when you say probability of A or B, think about your addition rule formula. So you're going to need to use that one. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Substitute probability of A or B is 0.57. So it's 0.57. Probability of A, we're not given it. So I'll write it as just probability of A, probability of B. They said probability of B is 2 times probability of A. So you can put 2 times probability of A here because you are given that. Then minus probability of A and B, it is 0 because we said these two are mutually exclusive. We're given that actually. So now you can solve for probability of A. So here we'll get 3 times probability of A. To solve for it, we divide both sides by 3, and then we get that probability of A will be 0.57 divided by 3, which gives us 0.19. Done. Again, note how important it is to know the conditions, mutually exclusive and independent, and then using your addition rule formula. Next example, we're given that for any two events, A and B, it is given probability of A and B is equal to that, probability of A or B is equal to that, probability of B is equal to 4 times probability of A. So they're saying you must first check if A and B are mutually exclusive. Justify your answer. So our first point is always 9.2.1. They say you must prove if, you must answer if A and B are mutually exclusive. Write the condition first for mutually exclusive. We said exclusive means that they don't have an intersection. So this means the probability of A and B is going to be 0. This is for mutually exclusive. So we want to test this condition. And then now, so we need to find probability of A and B. And if it is 0, we're going to say yes, they're mutually exclusive. But if it is not 0, we're going to say they are not mutually exclusive. How are you going to find it? We are given probability of A, probability of A or B. We are given this, right? So, which means that we can use it to find probability of A and B. In fact, we don't even need to do that because we are given probability of A and B is equal to that one. We are given, so we are given here probability of A and B is 0.12. It is not equal to 0. Therefore, we say A and B are not mutually exclusive. So we didn't need to calculate this because we already given in the question. And then the second question, they say find probability of B. So 9.2 points probability of B. How are we gonna find it?